Okay, tonight's class is about rescue tools, vehicle extrication, and technical rescue. Fire service electrical equipment. Auxiliary lighting used at a fire scene can provide an extra measure of safety to all firefighters. It provides additional visibility to avoid slips and falls, enables personnel to see potential hazards and traps which may cause injuries. Inverters, used on emergency vehicles when large amounts of power are not required. Converts vehicles current to 110 volt or a 220 volt AC current. Disadvantages include limited power output and mobility of vehicle. Generators can be portable or fixed to vehicles. Portable generators are powered by small gasoline or diesel engines and usually provide 110 and/or 120 volts. Vehicle-mounted generators produce more power than portable generators. They may be powered by gasoline, diesel, hydraulic, or power takeoff systems. They typically have outlet incorporated into the vehicle. Lighting equipment may be fixed on apparatus or portable. Portable lights range from 300 watts to 1,000 watts and may be on telescoping stands. Unless specially designed, lighting equipment must not be used in a flammable or explosive atmosphere. Most lighting equipment operates at high temperatures and can cause burns to unprotected skin. Gloves should be worn when changing quartz bulbs, as skin oil can cause a bulb to explode when turned on. The power of the lighting equipment should not exceed the output of the power plant. Cords and connectors are necessary to supply power to lighting equipment from the power plant. Cords must be insulated, waterproof, and have no exposed wires. Damaged cords should be repaired or replaced. Junction boxes may be used when it is necessary to connect multiple lights or tools. Junction boxes should be waterproof with the outlets covered. All outlets must have ground fault circuit interrupters, or GFCI, installed. GFCI protects against electrical shock. When grounding occurs, the device opens the circuit, stopping the power. Portable power plant maintenance and servicing. Review manufacturer's service manual for specific instructions. Check fluid levels weekly. Inspect the spark plug and spark plug wire for any visible damage, carbon buildup, or cracked porcelain. Check the carburetor for any signs of leaks. Start the generator and run any tests outlined in the operator manual. Do not start a generator under load. Do not run the generator for an extended period without a load. Test lighting equipment for proper operation while unit is running. Gasoline should not be added to a generator while it is in operation or if exhaust and engine are hot. Rescue tools can be used for cutting materials to free a victim, stabilizing vehicles or structural members, lifting a vehicle off a victim or raising a victim, pulling materials away to free a victim, breaking up materials to free a victim. Tools may be powered by batteries, vehicle electrical systems, or generators. A greater variety of battery-powered rescue tools is becoming available. The number of uses, speed, and power has made hydraulic tools indispensable in many rescue situations. Powered hydraulic tools receive power from hydraulic fluid pumped by a motor through high-pressure hoses. Most are powered by gasoline engines or electrical motors. May be portable or mounted to apparatus with hose reels for high-pressure hoses. Manual hydraulic tools. Hydraulic fluid is pumped manually through hoses, slower and have limited range compared to powered hydraulic tools. Pneumatic tools, powered by pressurized air, can use a large amount of air. The spreaders, or jaws, first type of powered hydraulic tools in the fire service. They're capable of pushing or pulling. Some can produce up to 22,000 psi of force. Tips may be spread up to 32 inches apart depending on the tool. Shears or cutters, capable of cutting almost any metal object. Some can produce up to 30,000 psi of force at the tips. May have an opening spread of about 7 inches. A combination cutter spreader has spreader tips on the arms with cutting shears on the inside edges, typically have less capabilities than the individual units, but are good for a small, rapid intervention vehicle. Extension rams, designed primarily for straight pushing operations, useful when pushing objects farther than the maximum opening of the hydraulic spreaders. They come in a variety of lengths. The size to be used depends on the opening in which it is to be placed. Cutting tools, used to cut materials away from trapped victims. Full PPE with eye and hearing protection must be used when using cutting tools. A power saw must never be used in a flammable atmosphere. Reciprocating saw. It's powerful and versatile. It has a short, straight blade which rapidly moves in and out. Blades are available for wood, metal, and concrete. A rotary saw, typically gasoline powered. Blades are available for wood, metal, and concrete. Carbide tipped blades are available which stay sharper longer. Pneumatic cut-off tool, a whizzer saw, much more maneuverable than larger circular saws. Carbon blades can cut case-hardened locks and steel. Often used in delicate cutting operations such as removing rings or cutting pipes to remove trapped fingers. Air chisels, also called air or impact hammers, operate at pressures of 90 to 250 psi. used for cutting sheet metal and popping rivets and bolts. They have a variety of tool bits. Rescuers must never work under a load supported only by jacks. The area under a raised load should be entered only when proper cribbing is in place. Manual hydraulic tools, hydraulic jacks, designed for lifting, can be used in shoring or stabilization operations, must be used on a flat, level surface, and may have capacities of up to 20 tons. Non-hydraulic jacks, screw jacks, can be extended or retracted by turning a threaded shaft. Bar screw jacks, not used for lifting, primarily used to hold an object in place. Trench screw jacks, used to replace wooden cross braces in trench rescues. Ratchet lever jacks, also known as high lift jacks, consist of a rigid I-beam with perforations on the web and a jacking cartridge with two ratchets on the geared side. They can be dangerous because they are the least stable of jacks. If the load shifts, the ratchet lever jacks may fall over. Buttress tension system, used to stabilize a vehicle on its top or side. It may consist of at least 4x4 inch posts wedged between the ground and vehicle. Commercial systems are available using metal struts and straps. Wheel chocks prevent vehicles from rolling when they are parked. Hard rubber, wood, aluminum, or urethane plastic blocks placed against the outer curve of a tire can be used to help stabilize vehicles involved in accidents. Cribbing, commonly used to stabilize vehicles, support roofs and ceilings. Wooden cribbing must be solid, straight, and free of flaws. Other than the ends, wooden cribbing should not be painted to avoid slips when wet. Commercially manufactured synthetic or plastic cribbing is becoming more common. It includes wedges, step chocks, struts, and pads for pneumatic lifting bags. Although more expensive, plastic cribbing does not become contaminated by fuel, oil, or other substances. Shoring, a series of timbers or jacks used to stabilize walls or sides of a trench. Rescue tripods, used for an anchor point above a utility cover or other opening. It allows rescuers to be safely lowered into confined spaces and victims to be raised out of them. Pneumatic lifting airbags help lift or displace objects that cannot be lifted with other equipment. High pressure bags, neoprene rubber exterior reinforced with steel wire or Kevlar fiber, about 1 inch thick deflated, depending on the size, can inflate to 20 inches, typically filled using SCBA cylinders. Low and medium pressure bags, larger than high pressure bags and used to lift or stabilize large vehicles or objects. Have greater lifting distance than high pressure bags. Airbag guidelines. Plan any lifting operation before starting. Operators must be familiar with the equipment and its limitations. Have an adequate air supply and cribbing. Position bags against a solid surface. Never inflate against sharp objects. Inflate slowly and watch for any shifting. Never work under a load supported only by airbags. Continually place cribbing under the load. Never stack bags more than 2 high with the smaller bag on top. Inflate the bottom bag first. Block and tackle systems. Useful for lifting heavy loads because of the mechanical advantage of converting pull into greater working force. Consists of 2 or more parts. Block, wood or metal frame containing 1 or more pulleys. And tackle, assembly of ropes and blocks that the line passes through to multiply the pulling force. Block and tackle safety. Be sure the rope is right size for the weight being lifted. Use a steady pull on the rope. Pull in a direct line, not at an angle. Be sure the supports holding the block will support the load. Stand in a safe position in case the tackle or support fails. Pulling tools. Used to pull vehicles apart, pull objects from victims, or stabilize a vehicle resting over an edge. Winches. Usually mounted on vehicles for quick deployment. Should have a handheld remote control to allow the operator to stand away from the winch in case the cable breaks. Personnel should be further away from the winch than the length of the cable being used. Winch operation guidelines. Always follow manufacturer's instructions. Inspect the cable and winch regularly and prior to each use. Inspect the winch mounts before each use. Never exceed the winch's load capacity. Have at least 5 wraps of cable around the winch drum at all times. Shock loads can exceed the capacity of a winch. Never wrap a cable around an object and hook it back to itself to avoid damaging the cable. Always place the hook so its back is facing the ground or away from the winch operator. Keep winch pulls as short as possible. Never step over or near a cable under tension. Never stand in front or behind the winch or anchor point. Use heavy-duty gloves and never let the cable slide through the hands. Drape a blanket or tarp over the winch cable for visibility and to reduce the recoil should it break. Never use a winch to pull a live person. Ratchet device, or the come-along. Manually operated winch that uses a ratchet and pulley assembly. The come-along is attached to a secure anchor point and the cable attached to the object to be moved. As the lever is moved to rewind the cable, the object moves forward to the anchor point. Rescue tool maintenance. Follow manufacturer's guidelines and department SOPs. Check all fluid levels. Keep batteries fully charged. Inspect power tools regularly. Inspect saw blades regularly and replace if worn or damaged. Check that all protective guards are in place and inspect hydraulic hoses and couplings. The majority of rescue incidents involve vehicle extrications. Proper extrication is vital to prevent further injury and speed a victim's removal. Any extrication should be coordinated with emergency medical personnel who are providing care to the victim. Scene safety must be the first consideration before starting any operation. Size-up begins with the dispatch and continues throughout the incident. You're looking for potential hazards, needed tasks and resources, traffic hazards, vehicle hazards, the number of victims, potential for fire, if there are any fluid leaks, potential hazardous materials, or if any utilities are involved. Proper apparatus positioning needs to be in a location which does not interfere with on-scene activities to provide a barrier to protect the scene. If possible, at least one traffic lane should be closed to non-emergency traffic in addition to the lanes where the vehicles involved are located. Control potential fire hazards. Extinguish any fires immediately. Isolate fuel leaks. Take steps to control possible ignition sources, like disconnect battery cables, deactivate undeployed airbags, isolate downed power lines, protect shock absorbers struts from heat. Check the interior and trunk for additional fire hazards. Looking for flammable adhesives, liquids, or solvents, illegal substances used to produce meth, ammunition and firearms, fireworks or explosives. Vehicles may have ignitable magnesium in numerous areas. Body fluids from the victim injuries can contaminate the vehicle. Follow blood-borne pathogen procedures. Protective clothing can become contaminated and must be properly cleaned. Precautions must be taken around physical hazards, such as broken glass and torn metal. Sharp edges should be covered or avoided. Broken glass should be cleared from the window frames and door sills. In addition to gasoline and diesel, responders may encounter alternative fuels such as methanol, ethanol, reformulated fuels, natural gas, propane, hydrocarbon, or biofuels. If a fuel system has been damaged, a fully charged hose line should be deployed. Electrically powered vehicles. Total electric vehicles are powered by a bank of batteries and/or electric motor. Hybrid electric vehicles are powered by electric motors and a gasoline engine. Vehicle electrical systems must be controlled by rescuers to avoid electrical shocks and ignition sources. Most vehicle electrical systems are either 12-volt or 24-volt systems of direct current. Electric and hybrid vehicles can have electrical systems ranging from 32 volts to 650 volts of direct current. Evaluate the need for extrication. The area around each vehicle involved and the entire scene must be assessed in detail. Rescuers should circle each involved vehicle to determine the vehicle's condition, any required extrication, or any hazardous conditions. Evaluate the need for extrication. The area around the scene must be surveyed to determine if any vehicles not readily apparent, any victims who have been thrown clear, or damage to utility services. Trained personnel should assess the conditions of victims and possible entrapments. More seriously injured victims should be treated and removed first. Other victims may have to be removed before the more serious patients can be assessed. Information must be forwarded to the IC concerning the resources needed, the order in which the victims need to be removed, the type of accident, the mechanism of injuries such as unrestrained victims, deformed steering wheels, etc. Stabilization is needed to prevent further injury to victims and injuries to rescuers. Proper support must be provided between the vehicle and the ground or other solid anchor points. The purpose is to maximize the contact between the vehicle and the ground to prevent vehicle movement. Rescuers must never push or shake a vehicle to test its stability. Stabilization is required for upright vehicles to prevent horizontal movement. Chock the vehicle's wheels, shut off the vehicle's ignition, set the vehicle's emergency brake, and place the transmission in park. Do not rely on the vehicle's mechanical systems as the only stabilization source. Preventing vertical movement. Jacks can be adjusted to the required height, but they can be time-consuming. Airbags can be positioned on each side of the vehicle, must be used in conjunction with cribbing. Cribbing. Built in a box formation with wedges for solid contact with the vehicle. Step blocks can be used for rapid stabilization. Rescuers must avoid placing any parts of their bodies under the vehicle when placing stabilization. Traditional methods or buttress tension systems can be used to stabilize vehicles found upside down, on their sides, or on a slope. Combinations of cribbing, ropes, and chains may have to be used to stabilize vehicles on their sides or tops. Adjustable struts can be used to stabilize a vehicle on its sides, constructed of square metal tubing with a base plate and a second tube that extends from it. Buttress tension systems are used to stabilize vehicles on their sides or upside down. Two buttress tension posts are placed on the least stable side of the vehicle at a 50-degree to 70-degree angle to a high point. 2 tension straps extend from the base of the long leg to the points on the vehicle. A third tension post is secured in the same fashion on the opposite side of the vehicle. Stabilization also requires shutting down the vehicle's electrical system. Before shutting down the power, lower power windows, unlock doors, and move seats back. Eliminates an ignition source and power to the restraint system. If the ignition is not accessible, power should be shut down by disconnecting the vehicle's negative cables to the battery. Cut the negative cable first, then the positive. Remove about 2 inches of each cable. Some departments use a terminal puller instead of cutting the battery cables. Electric and hybrid vehicles. Always assume a vehicle has power even without motor noise. Place wheel chocks in front of and behind tires. Place the transmission in park, shut off the ignition, and remove the key. Disconnect the 12-volt electrical system as with a gasoline-powered vehicle. Never touch, cut, or open any orange high voltage cables. Never touch, cut, or open any blue cables which contain an intermediate voltage charge. Consider the electrical system unsafe at last 10 minutes after ignition is shut off. Some vehicles may hold an electrical charge for up to 24 hours. Metal tools can cause electric shock if they contact energized areas of the vehicle. Review manufacturer's specific emergency response guidelines for common vehicles. Modern seatbelts have pre-tensioners that lock seatbelts in a crash to hold a person in place. Most are small pyrotechnic explosive charges which drive a concealed piston when sensors detect an abrupt deceleration of an accident. The piston rapidly drives a spool around which the seatbelt strap is wrapped, removing the slack from the belt instantly. Supplemental restraint systems, or SRS, and side impact protection systems, SIPS, airbags. Airbag systems can deploy at over 200 miles per hour with tremendous force. Accidental activation has injured rescuers during extrication operations. Airbags typically activate through electronic sensors and powered by the vehicle's battery. They have reserve energy supply capable of deployment after the battery is disconnected. The duration of the reserve power supply varies by manufacturer. Extrication activities can accidentally activate restraint systems. To prevent accidental activation on many vehicles, the ignition must be turned off and the battery cables disconnected and the reserve power supply allowed to drain. Side impact protection systems may be mechanically operated with compressed gas cylinders and can deploy without the vehicle's electrical system. There are no industry standards on the locations where these side airbags inflator cylinders can be mounted. They can be located in any of the posts along any part of the vehicle's supporting roof rail. All the posts should be exposed by pulling as much of the interior trim as possible prior to making any cuts and to operate out of the deployment zones of the airbags. If peeling the interior trim is not possible, cutting high on the post will give the best chance of avoiding any gas cylinders. Head Protection Systems, or HPS, deploy airbags from above the top of the door frames in a side impact collision. Window curtains automatically deflate shortly after deployment. Personal protective equipment must be worn and extreme care used when performing extrication on vehicles equipped with SRS or SIPS. Safety zone guidelines for working around inflatable restraint systems. 5 inches from side impact airbags and knee bolsters, 10 inches from front driver airbags, 12 to 18 inches from side impact curtains, 20 inches from front passenger airbags, but the distances will vary depending on make and model. Extendable Rollover Protection Systems, or ROPS, are designed to deploy automatically if a vehicle rolls over. They may be behind the front seat of small sports cars and in the rear deck of convertibles. Accidental deployment during rescue operations can cause serious injuries. Disable these devices by powering the vehicle down as soon as possible. Gaining access to victims. First, try the fastest and simplest methods, such as through an unlocked operating door or through a window. The more severe the vehicle damage, the more complicated and time-consuming gaining access and extrication will be. Once access is gained, a rescuer with emergency medical training should enter the vehicle to stabilize and protect the patient. After patient assessment, treatment can be conducted as extrication progresses. The vehicle is removed from around the patient, not the patient from around the vehicle. Packaging patients includes bandaging wounds, splinting fractures, and immobilizing the patient's body. Packaging protects the patient and helps with removal. Openings must be wide enough to remove the patient as smoothly as possible with a minimum of jostling. Vehicle glass may have to be removed for patient access and to prevent injuries. Rescuers must wear full protective equipment and eye protection. Vehicle occupants must also be protected. Safety laminated glass, formed from 2 sheets of glass bonded to a sheet of plastic between them. found in windshields and some rear windows. When broken, the glass stays attached to the laminate and moves as a unit. In some newer vehicles, the windshield serves as a structural component and the removal can weaken the vehicle. Removing laminated glass takes more time than removing tempered glass. Newer windshields may have an extra layer of laminate, making them more difficult to remove. Saws work best for removing double laminated safety glass. Use an axe, hay hook, air chisel, reciprocating saw, hand saw, or glass saw. The people inside a vehicle must be covered before starting the operation. Windshield glass is cut down to the short sides of the lower corners. Another cut is made across the bottom of the windshield. The windshield is then folded upward over the roof and removed entirely. Tempered glass. Vehicle side windows and rear windows are typically tempered glass. When broken, small fractures spread throughout and the glass breaks into small pieces. Use a sharp pointed object to strike the glass in the lower corner of the window to shatter the glass. A spring-loaded center punch can be used in a lower corner to shatter the glass. Rescuers and victims should be properly protected from the shattering glass. Self-adhering contact paper, duct tape, or spray adhesive can be used on the window before breaking to contain the broken glass. Removal of a vehicle's roof can provide open access to victims. Vehicle door post designations. In the front to the back, you have the A post, the B post in the middle, and the C post in the rear. Posts can be cut using a hydraulic cutter, a hacksaw, or reciprocating saw. For total roof removal, the A posts are cut first, then the B post, and then the C posts. An alternative method is to cut the A posts and the B and cut the roof in front of the B posts, then fold the roof back onto itself or the trunk. If the vehicle is on its side, an air chisel or reciprocating saw can be used to cut through the sheet metal. A vertical cut is made about 6 inches from the windshield down towards the ground. A second vertical cut is made about 6 inches from the rear window. A horizontal cut is made connecting the top of the vertical cuts and the roof is folded down. Many extrications involve the removal of a vehicle's doors for patient access and removal. Doors can be opened from the handle side or moved completely using a hydraulic spreader in the crack on the hinge side. The first step is to make a purchase point for the insertion of the spreaders. A prying tool is inserted into the crack at the handle side or hinge side of the door. The tool is used to widen the crack to a point where the spreader tips can be inserted. On the handle side, the spreaders are inserted into the crack above the lock mechanism and operated to spread the door away from the locking pin. On the hinge side, the spreaders are inserted above the top hinge and operated to break the hinge and then the bottom hinge. A victim may be pinned by a steering wheel or dashboard in a front-end collision. To displace the dash, the doors must be removed first. Relief notches are cut at the base of both the A-posts close to the rocker panels. Cut the upper portion and bottom portion of the A-posts. The ram is placed in the door frame against the base of the B-post into an area just above the top hinge on the A-post. As the ram extends, the dashboard is pushed up and away from the front seat area. A hydraulic spreader can also be used to push the dashboard upward and away from the front seat. Personnel must be aware that the bottom edge of the vehicle will be pushed downward during this operation and should remain out of this area. Cutting the steering wheel can be dangerous to the victims and firefighters. The airbag may deploy, the wheel may spring out forward. Avoid pulling the steering column. If a tilt steering wheel, the joint will easily break. A front-wheel drive vehicle has a joint along the steering column that may break, allowing the column to swing up into the victim. Firefighters should be able to identify technical rescue situations to determine the need for specially trained and equipped rescue teams. Sizing up the situation begins with dispatch information. What has happened? Where has it happened at? What type of rescue is it? The reported number of victims, and the need for rescue may not be known until arrival at the scene. Arrival at the scene. Note any hazards for responders and victims. Determine the priority of actions needed, and determine the need for additional resources. Communicating information on arrival by describing conditions found, any special considerations, initial actions needed, establishment of command, and resources needed. Stabilizing the situation by preventing it from getting worse. Blocking traffic, controlling utilities, suppressing fires. Establishing scene security, controlling the work area. Protecting bystanders from hazards. Setting up the personal accountability system. Accounting for victims. Protecting evidence and minimizing further collapse potential. Control zones must be established for the protection of personnel, victims, and the public. The hot zone includes the emergency site. Only individuals involved in mitigating the emergency are allowed in this area. All personnel entering this area must sign in to the accountability system. PPE is required for the specific hazard. All personnel in the zone need to be trained for the specific situation. The warm zone is immediately outside the hot zone. Only personnel directly supporting the work in the hot zone should be allowed in the warm zone. All personnel must be in appropriate PPE. The cold zone is furthest away from the hazard. Access is limited to working personnel involved with supporting the incident. The command post is located in this area. Surrounded by the crowd control line for the public and media. Personnel must understand the operations of technical rescue teams and be able to assist them with their operations. Firefighters assisting specialized rescue teams should confirm the instructions to assist the rescue team, gather the required tools and equipment as directed, provide the assistance as requested, maintain situational awareness, not work outside of their level of training or they risk injuring themselves and others. Rope rescue operations involve using life safety rope, harness, tripods, and accessories to access and rescue victims. High-angle urban structural rescue involve rescuing victims from scaffolding, towers, and other elevated areas. Wilderness mountain rescues involve rescuing individuals from cliffs, steep slopes, bluffs, and etc. Firefighters may assist rope rescue teams with carrying equipment and handling lines. Building collapse may result from fire, weather, earthquake, or age of structure. Rescuers should always consider the possibility of secondary collapse of a weakened structure. Rescue of heavily trapped victims should be left to specially trained and equipped personnel. Collapse categories. A pancake collapse can occur when opposing exterior walls fail, causing the roof and floors to collapse on top of each other. Type of collapse least likely to contain voids where victims may be found. The V-type collapse caused when the outer walls remain intact and the walls or roof fail in the middle. May create habitable voids on both sides of the collapse. The lean-to collapse occurs when the outer wall fails and the opposite wall remains. The side of the roof or floor which was supported by the failed wall drops, forming a triangular void underneath. A-frame collapse occurs when the floors or roof on both sides of a center wall collapse into opposing lean-to collapses. Provides a good chance for habitable voids. The cantilever collapse happens when one side wall of a multi-story building collapses and leaves the floors attached and supported by the remaining wall. Can create habitable voids under the supported ends, but these are most vulnerable to secondary collapse. Locating hidden victims in a structural collapse. Calling out and listening for a response. Using seismic or short-distance radar devices to detect vibrations from victims. Using enhanced acoustic listening devices. Using search cameras. Using thermal imaging cameras. Using search dogs. Collapse hazards, environmental hazards, damaged utilities, hazardous materials contamination, temperature extremes, and fire. Physical hazards, secondary collapse, working in unstable debris, working in confined spaces, working around wiring and rebar. Fire officials should seek assistance from structural engineers or construction experts when planning and conducting operations to secure area from further collapse. Remaining structure should be made as safe and secure as possible for rescuers and to prevent further collapse. Shoring, used to prevent sudden and unexpected movement of objects. Uses a series of cribbing, timbers, and jacks to prevent further collapse. Shoring is difficult and requires proper training and practice. Tunneling involves moving smaller debris to create a path to victims. Should only be done when other methods of reaching victims are not possible. Tunnels must be large for rescuer and victim. Tunnels should go along walls whenever possible. Moving debris for tunneling can cause other debris to fall. Common confined spaces where rescues may be necessary: tanks and vessels, silos, storage bins, utility vaults or pits, sewers, cisterns or wells, or storage tanks. Firefighters without specific confined space rescue training should perform only non-entry rescues and serve only in support functions. Confined space hazards. You have oxygen deficiencies, flammable gases or vapors, toxic gases, extreme temperatures, explosive dusts, limited means of egress, cave-ins or unstable supports, standing water, and utility hazards. Air monitoring and accountability are vital to the operation. Anyone entering a confined space must have a lifeline attached to his or her harness. Water emergencies. Personnel must always remember the difference between a rescue and a recovery. Rescue, where victim is stranded, floundering, or has been submerged for a short time. A recovery, when the victim has been submerged for such a long period that he or she is probably dead. Water rescues may be required with swimming pools, lakes, ponds, rivers and streams, swamps, drainage canals, water treatment facilities, or low-head dams. Some hazards of water rescue: undercurrents, debris, sinkholes, sharp rocks, extreme temperatures, chemical or biological contamination, dangerous reptiles. Low head or low water dams are extremely dangerous and are referred to as drowning machines. Water recirculates as it passes over the dam, creating powerful undercurrents. A person caught in the backwash will be carried to the face of the dam where the water washes the victim down under and back beneath the boil. All personnel should wear appropriate protective equipment that consists of a water rescue helmet, approved personal flotation device. Water rescue methods. Reach. Extend a long pole to the victim. Throw. Throw a rope or flotation device with an attached rope to the victim. Row. Use a boat. Go. As a last resort, swim to the victim. Place rescuers with rope bags downstream from the victim in case the victim or rescuers break free. Ice rescues. Consider all ice to be an unstable surface. The victim in the water proves the ice is weak. Thermal protective suits and personal flotation devices are mandatory before attempting any rescue. The victim's survival depends on how quickly he or she can get out of the water and get warm. The victim may not be able to hold on to a flotation device or rope due to hypothermia. Reach. If the victim is close enough to solid ground and is responsive and able to hold on to an aid. Throw. Throw a rope or flotation device with an attached rope to the victim if he or she is responsive and able to hold on to an aid. Only trained personnel should attempt to go out and perform ice rescues. A ladder can be extended to distribute the rescuer's weight on the ice. A flat-bottomed boat or raft can be pushed along the ice. Trench collapse. It can occur whenever excavation is going on in any jurisdiction. Rescuers can be killed in a trench collapse because they failed to stabilize the trench before entering. The first decision on a trench collapse is whether to consider it a rescue or body recovery. Some departments have a rule of thumb that if the victim is not visible, it is a body recovery operation. Most common problem is victims' reduced ability to breathe, and is the first priority must be to uncover the victim's head and chest to supply additional air. Air hose or smoke ejector may be used to introduce additional air into the area. Oxygen equipment may be used on the victim. Personnel must not be sent into trench unless trained and their safety can be reasonably ensured. Unnecessary personnel and heavy equipment must be moved away from the trench edge. Heavy equipment should not be used for digging unless the exact location of the victim is known. Only rescuers trained in trench rescue should enter a trench. A trench must be safely shored before being entered. Place exit ladders at each end of the trench. Tools must be used with caution to avoid injuring victim or rescuers. Be alert to other possible hazards such as electrical wiring, water lines, gas lines, toxic or flammable gases. Industrial accidents. Entrapments in industrial machinery are some of the most challenging rescues. Specific techniques cannot be listed because of the number of different types of industrial machinery in existence.
All personal equipment.
Sorry about that.
Minor rescue for 77031.12B.
When surveying an industrial accident, consider the victim's medical condition and degree of entrapment.
All personal equipment. Rescue for 77031.12B. 6616 Davis Lane near intersection of Loma Hillsborough Road. Happy Hill Subdivision 1532.
The number of rescuers required, the equipment needed, the need for specialized assistance, and the presence of other hazards. When it is necessary to extricate the victim, the first priority is to identify how the machinery operates. The machine may be operated normally to release the victim if further injury will not result. The machine may be disassembled. If the machine cannot be disassembled, it may be necessary to force the machine if this can be done without causing further injury. Use caution when turning off power supplies. Some machines, such as punch presses, operate in full cycle and may complete the cycle when power is shut off, causing further injury. Most elevator incidents involve a car stuck between floors due to mechanical or power failure and are not true emergencies. Elevators are classified by primary use. Passenger elevators accelerate quickly and have automatic controls. Freight elevators slower and have large access doors, may be automatic or manual. And construction elevators, these are similar to freight elevators. Elevators systems may be operated by cables, hydraulics, or a combination of the two. Cable systems are used in any size structure. Hydraulic systems are used in structures less than 6 stories. Elevators may malfunction because of physical damage, loss of power, overheated circuits, jammed or broken cables, emergency stop button activation, or electrical short circuit. Rescuers should contact building maintenance personnel and have an elevator mechanic dispatched to the scene immediately. Unless there is a medical emergency in the car, always establish contact and reassure the occupants that help is coming and wait for an elevator mechanic. Firefighters must never attempt to adjust an elevator's mechanical systems to move an elevator car. Elevator rescues require special rescue techniques and should not be attempted by untrained personnel. If evacuation of the car is necessary, determine the car's location and go to the floor nearest the stalled elevator. Establish communications with the passengers. Secure the elevator by opening the main power circuit to the elevator drive motor and remove the fuses and station a firefighter with a radio at the panel. Opening the elevator doors, usually done with a special key. Use forcible entry tools as a last resort. Escalators are chain-driven mechanical stairways. The steps are linked together on a track. The drive unit is usually at the upper landing and covered by a landing plate. Most escalators have an emergency stop control on a nearby wall or at the base of the escalator. The switch stops the escalator and sets an emergency brake. The stairs should be stopped during rescues or if firefighters are using the stairs to advance a hose. As with elevator emergencies, an escalator mechanic should be requested early in the incident. Most escalator emergencies involve fingers or toes becoming caught between the stop treads and guard plates. Shoes being wedging between the treads. Trapped fingers due to persons attempting to pick up dropped articles. And generally most injuries are not serious. The treads can be moved backwards by hand pressure, Older installations may require the use of a Halligan or pry bar to push the treads backwards. When pushed backwards, trapped fingers or toes can be easily removed and the victim removed from the escalator. Because of a victim's position and/or the extent of injuries, it may be necessary to remove the cover plate that covers the step treads at the landing. Remove the plate, screws, and lift the plate straight up rather than backwards or away from the victim. Following removal of the victim, place the escalator out of service. Tunnels and caves. Rescue requires very specially trained cave rescue personnel. Unless specially trained, firefighters must confine their activities to support functions above ground. Cave rescue major problems. Darkness. Cave water temperature is about 55 degrees. Irregular passages. Victims and rescuers may develop hypothermia, toxic gases, and oxygen deficiency. Electrical emergencies. Always assume that all electrical equipment and wires are energized and dangerous. Victims in contact with electrical equipment should also be considered as energized. The current must be shut off before any rescue can be done. Contact the utility company to shut down the power. Rescuers must stay at least a distance equal to one span between the poles in all directions until the power is shut off. Downed wires can energize fences, guardrails, and other metal objects for some distance from the wires. Downed energized wires can cause current to flow across the ground in all directions. As the current flows away, the voltage drops, referred to as the ground gradient. Depending on the voltage involved and ground moisture, the energized field can extend several feet from the downed wire. The majority of rescue incidents involve vehicle extrications. Proper extrication is vital to prevent further injury and speed a victim's removal. Scene safety must be the first consideration before starting any operation. Firefighters must be able to identify technical rescue situations to determine the need for specially trained and equipped rescue teams. Personnel must also understand the operations of these teams and be able to assist with their operations.